This video covers chapter 24 from the Higher textbook, and it covers algebraic fractions and functions. So first of all, let's start off with functions, and they're linked to functions or function machines that you would have done probably back in year 5, 6, 7, and we've just got a new way of writing a function. So the notation is, you'll see something like this: fx like this, or gx, or hx. It could be any number like this, and actually it could be any letter. So it could be I don't know, G, A, H with a T. It could be any pairs of letter, but this is the notation: a letter followed by another letter in brackets. So from year 7 or year 6, you'll remember that maybe we put a number into a function machine and we do a couple of things to it. So it might be times by 6, then it might be add 7, and then you get some sort of output. And then when you started doing algebra, maybe you looked at putting a letter in here and see what comes out. So what would have come out on this one would be 6 times x, 6x plus 7. Now what we can do using this new notation, we can say this, that this function that has x as the input is 6x plus 7. So whatever letter we put there, that's the input. Yeah, now that input may be a letter, or that input may be a number, and we'll deal with both. But once you've said what a function is, we can then use it over and over again. So we've just made up this function here, which is f of x. That's what we say is 6x plus 7. So if I now had this question and I needed to work out f of 3, well, now 3 becomes the input into that function. And what do? I do 6 times 3 plus 7. So that'd be 18 plus 7, that'd be 25. Or it could be that the input is 0, it could be anything. So that'd be 6 times 0 plus 7, so I'd end up with 7 coming out, that'd be the answer. Or it could even be negative or a decimal. Let's say it was negative a half. So that'd be 6 times negative a half, which is minus 3, plus 7 would give me 4. Yeah, so we're doing things to this function, we're putting different things in. Or you may get a question that says something like this: solve the function equal to 10. And this is basically solving an equation. Yeah, solving an equation. So the first one was substituting, wasn't it? So when we did these bits here, yeah, this was substituting basically, and now we can do some solving. So rather than write f of x, we write down 6x plus 7 equals 10, and we solve this. So you take away 7 from both sides, so you'd have 6x equals 3. Then we would divide both sides by 6. I have x equals 3 over 6, which is basically a half, or 0.5. Or it might be that I've been asked to solve f of x equals negative 2. So now we write 6x plus 7 equals negative 2. We solve it just like before, we take away 7 from both sides. So I'll have 6x equals negative 9. Divide both sides by 6. And I'll have x equals negative 9 over 6, which I could leave like that. Or divide both by 3 and have negative 3 over 2, which is the same as negative 1.5. So you can see with a function, once we set it up, we can substitute or we can solve. Now what else can we do with functions? Well, we can find the inverse of a function. Now the notation we use for inverse is we put a little -1 like this, just like we do with sine inverse, cos inverse, tan inverse. Yeah. So let's take our function that we set up before, which was 6x plus 7. And the question says that we need to find the inverse. So the easiest way to do this is to use a function machine. So what was the function machine? We start with x, we times by 6, we add 7, and then we get our output. So the inverse, we just do everything in reverse. So we put x in this way, we take away 7, we divide by 6, and whatever comes out this end is the inverse. So that would be x minus 7 all divided by 6. Now if the inverse is a bit harder, let's say for example that my function, let's call this g of x, was something like this: x plus 2 over x minus 3, then we can't use a function machine because x appears in two places. So if I need to find the inverse, we use a slightly different method, and this is to do with changing the subject. So the first thing that we would do is that we would write, instead of g of x, I would write y equals x plus 2 over x minus 3. And what I need to do is to make y the subject. So to do that, I'd probably start by multiplying both sides by x minus 3 to get rid of that nasty fraction. So I'd have y times x minus 3 equals x plus 2. Then I'd expand the brackets and have xy minus 3y equals x plus 2. Now I want to make x the subject, so I'll bring both the x's to the same side. So I'd have xy minus x equals 2 plus 3y. Then I'd factorise, so I'll have this, and then from there I can make x the subject, so it'd be x equals 2 plus 3y over y minus 1, and this is my inverse here. Yeah, so I could now write that g negative 1 of x, the inverse, is 2 plus 3y over y minus 1. That's what we do if it's a bit more tricky. Another thing we can do with functions is composite functions. This is where we put multiple functions together. So let's make some different functions up. So we'll have f of x is x squared minus 3, and function g is going to be 7x plus 11. Now, composite function, you're going to see things written like this. Yeah, two letters written together. You may even see the same letter written twice like this. But what's important is that the second letter is what we do first. And you'll see what I mean in a moment. So basically what happens, so if I were to show you what we would do with something like this, this means that you start with x, you put x into function g, then whatever comes out of function g goes into function f, and we get our output. If I was doing this one, for example, then again we would start with function g, because that's the one that's closest to x. You always start with that one first. Then what comes out of g then goes into h, and then we get our output. And then this one, for example, you start with x, it goes into, well, let's do a different letter. So rather than x there, let's say this had the letter A. So that means what we do is we start with the letter A, that goes into function g, and whatever comes out of g goes into g again, and then we get our output. So let's do a couple of examples. So let's say I did, or this question said, can you work out f g of x? Right, so that means we start with function g, which is 7x plus 11, and then this 7x plus 11 goes into function f. Now what does x do? This function f do? Well, it squares the input and then we take away 3. Now the input is 7x plus 11, so that gets squared and we take away 3. Here's another way of displaying it, this might help. So x goes into function g. What does function g do? So I'll write it like that. Well, if x goes into g, what comes out is 7x plus 11. Now 7x plus 11 goes into function f. Now what does function f do? Well, it squares the input. So the input is 7x plus 11. And we take away 3. Okay, what if the question said to work out this? Gf of x. Right, so this means that we start with f, which is x squared minus 3. That goes into function g. Now what does function g do? 7 times the input plus 11. So 7 times this input plus 11. So again, if I used like little function drawings to show you what's going on. So we start with f. What does function f do? Well, it's x squared minus 3. That goes into function g. What does function g do? Well, it takes the input, which is this, x squared minus 3. It gets times by 7, and then we add 11. Okay, and you could expand the brackets and simplify that. Sometimes we put numbers into functions, yeah, so I may have a question something like this. It may say, what's fg of 2? Now what this means is to put the number 2 into g. So I'll put the number 2 into g first. Remember, you always do that first. So that'd be 7 times 2 plus 11. So I'm basically starting with 2. It's going into g. Now if 2 goes into g, out will come 2 times 7, which is 14, plus 11, 25. So that's 7 times 2 plus 11. And then 25 now goes into function f. So that's going to be 25 squared minus 3. So I'm going to need to calculate for that. So 25 goes into f, not g. Then what will come out is going to be 25 squared. I don't know what that is. I'll use the calculator. 625 minus 3. So 622. So 622 comes out, and that is 25 squared minus 3. So if the input is a number, you don't need to work out all of this. All you do is put the number into the first function, which we did, and out pops 25. Then 25 goes into the second function, which we did, and we got 622 as our final answer. So on a question like this, 622 would be your final answer. Right, we now move on to this topic here, which is algebraic fractions. And algebraic fractions have the same rules as normal fractions. So if we are multiplying algebraic fractions, so if I had something like 3x minus 2 over 6 times by 4x plus 1 over 5, then we multiply the top times the top, so it's basically like expanding brackets, so that'd be 12x squared plus 3x minus 8x minus 2 over 30, so I could simplify that as 12x squared minus 5x minus 2 over 30. Yeah, so just like normal algebraic fractions, top times top, bottom times bottom, so I could have something like 4 over x plus 1 times by x 2x plus 3 over x minus 1. So I would have, again it's like expanding brackets because you're just timesing, so the top I would have 8x plus 12, the bottom when I expand the brackets, x squared minus x plus x minus 1, and if I simplify that I will have 8x plus 12 over x squared minus 1. When we divide algebraic fractions, we use the KFC, keep the first fraction, flip the second fraction, change the sign. So let's say I had something like 4x minus 2 over 7x plus 3 divided by, don't need brackets, x plus 3 over 2x minus 1. So we'd keep the first fraction, we'd flip the second, and we'd reverse the sign, which we've done. And again it's just like expanding double brackets. I'll put the brackets in now. So you need to be good at expanding brackets. So that will give me 8x squared minus 4x minus 4x again plus 2 all over 7x squared plus 21x plus 3x plus 9. And just like before, we would simplify it, and I'd get 8x squared minus 8x plus 2 all over 7x squared plus 24x plus 9. When we move on to adding and subtracting algebraic fractions, then the rules are just with normal fractions we make the denominators the same. Make the denominators the same. So we'll do a couple of examples. Let's say I had 3x minus 1 over 2 plus 4x plus 7 over 5. I need to make the denominators the same, so I would multiply the top and the bottom of this fraction by 5 and the top and the bottom of this fraction by 2, so I get 10 at the bottom of both. So I would get 15x minus 5 over 10 plus 8x plus 14 over 10. Now we can add them together. So I'll have 15x minus 5 plus 8x plus 14 all over 10. So that will give me 23x plus 9, 5 minus 14, or minus 5 plus 14 over 10. Yeah, and the same would apply for your subtracting. Let's do a quick subtraction one. let's say I had 2x plus 3 over x plus 7 minus x plus 5 over x plus 1. Now what I need to do with this, I need to multiply this fraction by x plus 1, the top and the bottom, and this fraction I multiply the top and the bottom by x plus 7. That way I'll get the same thing in both denominators. So when we do that, and we're not going to expand brackets just yet, so I'll have this in the first fraction, so you can see the x plus 1 at the top and the bottom, and then minus, then the second fraction, I should have this x plus 7 in the numerator and denominator. Okay, so now you can see we've got the same thing in both denominators, so we can move on to the next step, which is expand the brackets at the top. So if I do that, it will be a lot of stuff. I'll have 2x squared plus 2x plus 3x plus 3, that's from the first bracket. From the second one, I'll have x squared plus 7x plus 5x plus 35, run out of space, all over, and this will be x plus 7, x plus 1. So all we do is tidy up the top. So I'll have 2x squared minus x squared, because there's a minus there, just leave me with x squared. Then I will have 2x and 3x, which is 5x. Then I've got to take away 7x and 5x, so it's like 5x minus 5x, which is 0, minus 7x. Remember, you've got to keep minusing because the minus is in the middle. So all I'm left with is minus 7x. Then I'll have 3 here, minus 35. So 3 minus 35 is going to be negative 32. All over. Now I could expand the brackets or just leave it as it is. Now sometimes on questions like this, you might be able to factorise the top, and if for example we factorise the top and we had one of these in the brackets, we could then cancel it out. Okay. Now the last topic we're looking at here is iteration, to find a solution to an equation to a suitable degree of accuracy. Now iteration is basically having some sort of starting value to solve an equation, putting it into some sort of formula, getting a number that comes out, and then just put it back into the formula again. So you just go round and round in a loop. So iteration questions often look like this. You'll see this type of thing. And part A of a question might be you need to rearrange some sort of equation to look like this. Yep. And then next to it, it'll say something like this x0 or x1 is this. So what does all of this mean? Well, this is your starting value. That's what we're going to start with. And what we're going to do is that starting value is going to go here. We'll put that in, and then the first time we put it in, we're going to get a value that comes out, and that will what we call x2. Now when we get x2, we'll put that in here, and then we'll get another value which is x3. When we get x3, we put it in, and then we get x4, and so on. Now the quick way of doing this on your calculator is first of all to put the starting value in and then press equals. So saves you typing it in over and over again. So start quick method. So type in starting value. So in our case, that starting value is -1. Then press equals. Now what happens is that starting value will then get stored on equals or answer. So I'm going to do that now, -1, and just press equals. That's step number 1. Step number 2, we're going to type in the formula or equation. That's not an equation. Type in a formula, but type in or press the answer button where you see xn, like this. So actually what I'm going to be typing in on my calculator is I'm going to press the answer button, cubed -3/8. Then to get x2, x3 and so on, we just keep pressing equals, and that will give you the other solution. So let's do it over here. So x1, that starting value is -1. Okay, so I did -1 equals. To find the next value, so I now type in, I press the fraction button, and I press the answer button, and then I press the cubed button, then -3. I scroll down to the bottom of the fraction and press 8, and I just press equals. Okay, so as soon as I press equals, I get -1/2. Then I press equals again. Now I get -25/64. Then I press equals again. This time I get -0.382, and it carries on, and I'll press it again. I can keep going. x5 equals -0.3819, like this, and I can see it's starting to stop jumping around, and actually by the time I get to the next one, it's almost identical to the previous one. Yeah, so this is what we would represent the solution. So this is the solution to the original equation. That's a nice easy method. So this is a question that you should be able to pick up lots of marks on, as long as you remember how to type this in on your calculator. So this now covers the whole of chapter 24.